Hello everyone. Welcome back to the another session of Serverless Saturdays. And myself Dharmendra, and I have Susit with me. Hello
So,
Susit. How are you?
hello, hi Dharmendra, hello everyone. So there was a small break last month where we did not have any session. That was because of the Hero Summit that happened in Seattle. You might have seen the posts on LinkedIn and elsewhere. Uh, so yeah, we are back again for this month's Serverless Saturdays, and we have an exciting session. I hear Dharmendra.
Yes. So today we are joined by our speaker Daniel Muller. He's from Portugal, joining us early morning today. And so let me introduce him to you guys. Uh, hey
Hey,
Daniel, good
Daniel.
morning.
Hello, good morning, good afternoon, good evening.
Thank you
Well,
for
it depends
joining us.
from where you are watching.
Yes. So Daniel is working as a solution architect for Serverless Guru right now, but he have experience of working with uh, servers in some rooms with cloud services now. So uh, he has experience. I think he is working from quite of some time in this industry. So I will over to you, Daniel, and there we go.
Yeah, hello everyone. So, as thanks, Daminda and Sush, to have invited me. And as you mentioned, yeah, I have a few experience. So I'm working in the IT world since, well, working since 2000, toying with it since 96, and yeah, working with the cloud since roughly 2011. And serverless when it started, like 2015, 2016. And yeah, I used to run stuff on my own servers in a freezing basement, and I used to do apps on serverless, and now yeah, more doing an architect role, so a little bit less inside VS Code, but still trying to not lose touch with the real world of the devs.
Awesome.
Okay.
Thank you once again, Daniel, for joining us so early in the morning. We're really excited to listen from you. And I mean, the session itself, the title especially looks very interesting. So over to you. Yeah.
Yeah, so let me just start my slides, share screen. Okay, yeah. So to be honest, it's kind of an old presentation I did, and I added like a little bit more modern spin on it by trying to make serverless and Kubernetes compete. And that's like, so the question is there still a place for serverless in a Kubernetes world? So that might perhaps for some of you come as a surprise. Like, why do we try to pitch serverless against Kubernetes? Isn't Kubernetes serverless in some ways? We will answer that. We will see that. But to answer the question, is there a place for serverless in a Kubernetes world? I think we can already start with a spoiler alert. The answer is yes. That's not the end of the presentation. I go into it to explain why. So, as I said in the intro, so about me, a few so that you know what's my background and where I'm coming from. I'm an AWS enthusiast, serverless enthusiast. I've been managing racks in a freezing basement, as I said, and I have toyed. So I'm not from an IT background, but I've toyed with IT since the beginning of internet, basically, or like mass internet for the masses. And now I'm currently working as a solution architect for a company called Serverless Guru. So, okay, so the first question, because some people might be offended that I don't treat Kubernetes as serverless. So isn't Kubernetes serverless? So why is it not? So first we need to go back to the basics and try to redefine or rememorize what serverless means. And I think that differs for every person. So that's like my point of view of what serverless means, and my point of view why I wouldn't treat Kubernetes as serverless. So first, serverless, it means for me, no infrastructure to maintain, and you have no OSs to patch. If you have worked with servers, you know that every once in a while, you need to shut down everything, do an upgrade, reboot, and put everything out of business for half an hour. Then the second point, and that's probably the more important ones, the two next one are the most important ones, that you pay per usage. So it means that if you are not using it, you don't pay. So you don't pay for idle. And that's the really important part. It's not to pay for idle. So if you don't use the service, or like nobody's using your service, there's nothing to be paid, no fixed cost behind it. Then you have some inbuilt functionality that should be there, like automatically scales up, automatically scales down. And by scaling down means it can scale up to 0, which come again back to idle. And we also expect from a serverless service to have built-in fault tolerance, built-in security. And when I say fault tolerance, it's not on your application, but about the underlying infrastructure. So the hardware that runs your serverless tools should manage themselves the fault tolerance about hardware, networking, and so on. And so that's why serverless becomes a matter of point of view. Because don't tell everyone, but there are still servers behind serverless. It's not because it just not magically run out of thin air. That there is a rack somewhere that runs your application and someone is managing that. So take an example of the first company. They are only doing Lambda-based solutions. So this company has developers. They will deploy functions to AWS, and that's it. So what do they achieve with that? They will pay for usage only. They don't pay for idle. They have auto-scaling, which means they are running a serverless stack here. Now, an example of the next company, they're doing the same, but based on Kubernetes. So they will have a Kubernetes host. They will start to deploy containers, run that into AWS with ECS or EC2. Now, they will have to pay 24/7 infra just to manage the Kubernetes hosts. They will have to manage those OSs, and they will need to manage the scaling based on some rules, traffic, CPU, memory. Now, this company is no more doing serverless because one of the key principles that you don't pay for idle is no more met, and managing OS and so on. Obviously, that's a really broad or simplified view, because if you enter now the ECS world and then even more the Fargate world, a lot of these points comes blurred between serverless and servers stacks. And now take another example of another company. They're a little bit bigger, and they have two teams. They have a dev team and an infra team. So your infra team will actually run the Kubernetes cluster. They will start to pay. They pay for the 24/7 infra. They manage the OS. They manage the scaling. So they are clearly not running something serverless. And they are also taking in the bill for their part of the job. And the same company has a dev team who will just deploy containers to the existing cluster. For them, they will only pay per use. They won't pay for idle. And they have the auto scaling that was provided by the infra team. So in that case, the dev team will actually see Kubernetes as a serverless application because they don't have to care about everything that's like the server part of it. So that's why some people might see Kubernetes as being serverless, because they don't have to manage the underlying infrastructure. But what have they achieved here, this third company? They actually just transferred cost from AWS to their own company. So it means that the infra cost, the human cost, is just transferred from AWS to their own company. That's just a point to make, that sometimes we think that our AWS bill might be too high, and often it is. But if you want to do yourself all the heavy lifting that your cloud provider, be it AWS or any other cloud provider or any service provider does for you, you will have to shift the bill from one bucket to another. So now, what technology should be used? Like, does serverless still have a place? Because Kubernetes is everywhere. People love it. And people have always good argument in favor of it. So let's take a little example. It's all fictional. All these people are AI generated, they don't exist. So we start with Samantha. Samantha is from marketing, and she has a new initiative. She wants to publish a travel blog series featuring many pictures from the region featured in each article. So every day, every week, there's a new region they want to feature. A lot of pictures. There's like, the articles are heavily picture focused because she wants the audience to be drawn into the landscapes and the lives and of the region. And most importantly for her, it needs to look perfect on every device. So if you come from your TV screen, you come from a mobile phone, everything needs to like be pixel aligned, a nice picture, good quality, crisp, and so on. So we go back a few decades, go back to pure HTML. So how do you serve an image on the web? So we all know you have your image tag, your source of the image, you define a width and the height. And that works perfectly fine on your desktop. It's super nice. It's exactly what Samantha needs. But now a few more clients arrive. You have TVs, you have mobile phones, you have tablets, you have laptops. And suddenly your image that looked perfect on your desktop is like super tiny on the other devices, doesn't fit the whole screen, isn't crisp enough. So that's where you start to create more sizes, more formats to fit all those devices. So you can see your little image tag that was like just a little one-liner becomes now a big block with multiple sizes, multiple formats. So, and a fallback image. So here we have already 11 different versions of the same image. But now, perfect. It works fine on every device. All the devices that we can test on, we have the exact sizes that we need. And then I listed here, and that might have changed inside these slides. You suddenly start to have like so many screen sizes, like be it Android, be it from iOS, be it from the different TV or TV setup boxes that exist. And they will all have their own definition, their own width, their own height, their own pixel density. And the question we can ask is like, why do we actually bother with these different sizes? Why can we not just ship a huge image and let the client reduce it to fit its own screen? So first, it's a matter of user experience. Nowadays, it's again, like more the decades advance, it's less a problem, but it's the load speeds. So if every time you have to ship a huge image and you have 20 of them on your page, the user experience will suffer because the load speeds will be longer, or the speed will be slower and the time will be longer. And then also, by shipping an image that has the right size, you get a better quality for the content. So having the client browser resize it that's CPU memory that will be impacted, and also aspect quality. But for you as a company, it's also cost control. If now you have hundreds of people coming to look at your images, and you all the time ship the high resolution one, you will have to pay for this bandwidth. So I'm speaking about CDNs and outgoing bandwidth from your data center. So by reducing the image sizes to match the client's displays, you will be able to reduce your own bandwidth cost. So now we've seen all these images, and now we go to the office of Jason. Jason is from design, and he's the guy in charge of creating all these pages, creating all these images. But he is kind of turning crazy because every month there's a new screen size that appears in the world. So he has to redo all his images, all the pages on which he already worked, perhaps last year. And suddenly all these old images, he has to regenerate a new version for them. And that's like, as you can see in his facial expression, making him very, very angry. So now we call Brian from IT, and he says, yeah, let's upload the image to the cloud, and we will resize the image on the fly depending on what the viewer needs. So saying that if I have a TV screen, a full HD, I need a 1080p image. If I'm on a retina display, I need probably 4 times that size. So now that Brian has a good idea, we turn towards the implementation guy. So that's Luis from Cloud Infrastructure. And he's like, oh, easy, let's use Kubernetes. We can scale our application infinitely. It works anywhere. The problem is just we will need to hire 4 more people to do the 24/7, 365 shifts to keep the whole stack running all the time. But that will reduce our cloud costs. So I'm on purpose here, so that's why the little asterisk on the bottom. I'm a bit sarcastic on that. I'm kind of just wanted to show, like, yeah, if you start to run your Kubernetes cluster, you will need people that understand it, that are able to run it. And that's obviously added cost on your end. And we often forget that when we start with a new technology that we don't know. So he proposes his schema for that. So you start to have like a data plane, you have a control plane, you have a few worker nodes. Each node will have some pods inside that will be replicated for load balancing and for recovery. And yeah, we all know that will work nicely. We have some Node.js application to serve the pages. We have some Python application to serve the images. We have some MySQL clusters to store all these images and keep track of versions and where they are and what's their endpoints. We have some storage, with some load balancers in front, and so on and so on. So, okay, so let's look a little bit on genetic images on the fly and what solution we could use. So first, we have the in-house solution. So it means that you have your own data rack, a server rack with your servers inside. So that's obviously a huge upfront cost. You will have maintenance cost. You will have to pay electricity, bandwidth, AC, and obviously pay the rental of the building. And most importantly, if you're looking compare that to serverless, you will pay for idle. So if you have nobody coming to consume your site and your images, Your servers will still run, that's still electricity cost. Your AC will still run, that's still AC cost. You still have to pay the rent for your building. So that's not really a good solution. Then you could move anything to the cloud by using cloud instances, EC2 or Docker or Kubernetes. You still have maintenance cost because you still need to manage your OS, your configs. Your auto scaling, especially with EC2, is kind of a slow to start. So it will take time before you can scale. You still pay for some idle, less than in-house, but you will still pay for some idle. So now Bob from development, he's like working on this website and he's like thinking, yeah, why can't we not just use serverless? There's no overhead, there's no maintenance, there's no OSs to patch. And when there's no traffic, we just don't have anything in our bill. So when traffic reduces, our bill reduces. And by using serverless, especially Lambda, I would say, Bob doesn't have to be on call 24/7 because he knows how it scales. He knows that there's resilience built in. So there's way less worries. So let's try to create all the sizes of these images on the fly serverlessly. Can we do that? So there's multiple ways that we can achieve that. First is the simple one, or the first one that we will jump to. It's just an API gateway, a Lambda function, and a bucket. And every time there's a request, we fetch the raw image from the bucket, resize it, send it back. So that's easy to set up and maintain. Like, that's a well-known pattern. But obviously, there are some cons for it. Every image that we generate, or every image that is served, will be a Lambda invocation, and there's no CDN. Or you could put your API gateway in edge optimized, but let's not really consider that as CDN because you don't really have control over it. So now, then you could actually go to putting some Lambda edge on CloudFront. So directly take the image from the bucket, the raw image from the bucket, transform it and push it back. Now you have a CDN. So now you are storing your images in a CDN, and the Lambda is only invoked on a cache miss. But if you have worked with Lambda Edge, you know that's a little bit harder to maintain. And there is a few limitations in Lambda Edge. So in the first version of this solution, I tried with Lambda Edge, and I quickly reached the max body size limitation of Lambda Edge. So it means that Lambda will read your image from the bucket, transform it, and then try to push it back to the client. But the image was too big, and I exceeded the body size limit of the Lambda Edge function. So let's try to find something that's more simple and more cost-effective than the two first approaches. So for that, we have to make some assumptions or some limitations. We'll first say that the client know what they need. So the client, when I say client, is the device. The device knows its screen size, knows its pixel density, and knows the formats that it supports. And then we will pass all this information just in the URL as a path. So if you see this URL below, you have the first part, which is the original path. So that will be the source of your image. Then we have a version here. So the version is just to allow having the same image in different versions. So if you upload a new source image that has the same name, we will actually increase the version number here, and that will allow to create a new cache entry in the CDN without having to purge the CDN in advance. Then we have another part which is dimensions. So dimension will, with that part we can tell which width, which height, which pixel density we need. And then we end up with a display name and a format. So format is nowadays not really important anymore. All the browsers now supports WebP. In my first version of this solution, there were still a lot of browser, like some were WebP and some were still JPEG. There was like a 50-50 between both. So the browser was telling, yeah, I support WebP or I want JPEG. And now it's, why use like a path with all that? Why not use query string parameters? So the benefit of the path is that's easy to cache, be it from the client, from the CDN. You, like path is something that's like the basic of any HTML or HTTP document. And it's not that hard to extract the parameters, because if you, as long as you don't have slashes inside every variable, you just split on them and you get every single part of it. And another important part with that, since we pass in the original path as the first parameter, not an image ID, there's no database needed to reference the raw assets. So with that, we eliminated the need of a database, and which also like obviously reduces cost and complications. So what will the request flow look like in such a solution? So the happy world example, your asset is already cached in a CDN. So your consumer, your client, will now reach to your endpoint, to your image URL, and the CDN will just reply with the image. But now if the image is not cached at the CDN, so the same request comes in, CDN doesn't have it in cache, it will go to an S3 bucket, fetch this file, mytitle.webp from this bucket, put it into the CDN, and then serve it back to the client. But that's all nice if the image is pre-generated. If it's not, and that's where the whole creating an image size on the fly comes in. So your request will come to your CDN, and the CDN doesn't have it in cache. The CDN will look up the source bucket, and there's no image there with that name or with that path. And what we will do in that case, we will return here with a 307, HTTP 307. We return a redirect to the client to tell him to go to another URL, which this time, instead of being the CloudFront URL, it's an API gateway endpoint with the exact same path here than we had initially. So now this response here comes back, HTTP 307. Now the client will issue this request again, now going to an API gateway. This API gateway will invoke a Lambda function that will now know where to fetch the raw image. Remember, the first path here is the path to the raw image. We will fetch that from the source bucket, transform the image, and now store it back to our assets bucket or cache bucket. And now we again return with a redirect, this time a permanent redirect. So 307 was temporary, 302 is permanent. That now we return the URL, but this time with the CDN. domain instead of the API gateway domain. So as you can see, these two are very similar. The only thing that changed is the domain part. And now the client will do the same request that it did at the beginning. So if you look here, the first request and this one, they are exactly the same. There's no difference. But this time, the cache exists in the bucket. The CDN can load this image, put it in the CDN, and serve it back to the client. And now our image here, we have generated a thumbnail with 272 width, 181 height, cropped to the exact dimensions. That is now stored in this S3 bucket, in this cache S3 bucket, and be able to serve to a CDN. So any other client from anywhere around the world that has the same image size needs will have this image created, and he will directly be served either from the CDN or from the bucket. So every other client that now comes in with the same request will only have to worry about this flow here, and we don't need to hop to point 2 and point 3 anymore. That means that only the first request for an image that has never been generated will need to call to the API gateway Lambda function to be generated. Okay, so a few words on the path. I already touched on that. So the first part of the path is the location of the image in the row bucket. In the row bucket. Then we have a version that's just to do cache burst. Then we have this dimension, which are like, I would say, commands or that are separated by commas. Then we just have a title that's more to look like more human, and it helps a little bit with SEO. And then we have a format, WebP or JPEG. So what have we done with this solution? It's a simple solution. It's cost effective. So on the right, you have the full, I would say, the full schema. There's really like not much. An API gateway, a Lambda function, a CDN, CloudFront, and 2 buckets. And what's good with that is we are now using a CDN for repeated requests. So now if 2 different persons are fetching the same image, they will all use what's inside the CDN. The resized images are all cached in S3. So that's cost effective, and you don't really have to worry about hard drives. And we only generate the image when the cached version is missing. So the pros is that it really behaves like a static image host. So I make the difference that it is now a static image host because we created all these variations for each image. There's a huge emphasis on caching. And most importantly, is like there's no idle cost. So if nobody is coming to consume your images, you don't have CloudFront traffic to pay, you don't have API gateway to pay, you don't have Lambda invocations to pay. You will still pay for your storage because in a way it's not idle because you are using the storage. But that's the only part that you will continue to pay if nobody comes to consume your images. But with any solution, there's like pros and cons, and obviously there is cons here also, and some of you might already have noticed them. The first request will be slightly slower. So we are looking at 2 redirects and an image generation, and we will see later how much slower it is. So for one single image, it's not that dramatic. You don't really notice it. But imagine you have a page with 200 images on it. Even if they are all been done in parallel, you notice that they are not coming from a CDN. And the other con is that there's also slightly more work on the client side. So when in that case, the client here is not a human or a device, it's the website itself, the client, the website that holds the images. He will need to pass all the information he needs, like the width of the image that he needs, the DPI that he's capable of doing, and the format that he can use. Okay, so I think it's time to move that to something less slidely and more shell-based or VS Code-based. Oops. Let's clean all that. Okay, so don't be too scared about all these files. It's a really simple serverless YAML or serverless framework based application. Zoom in, zoom in. I just split that in several files for making the code a bit more clearer to manage. But if we look at our application, we have a handler that will use an API gateway v2, and we just extract the path parameters, folder, file name, the transformation, which was the dimensions, and the image name. And then based on that, we will just build an image. So everything here is using an NPM library called Sharp. You could do that in any other language, obviously. And that's where all the magic happens. So we will pass all the transformations. And then I won't go into too much detail here, but based on the key, so you've seen that like you had like width and height. So that will actually give the width and the height of your image. DPR is the pixel density. If you just have a width and you need a fixed aspect ratio, you can pass a parameter called AR as aspect ratio. So the client could say, oh, I want an image that's 200 pixel or 400 pixel width, but in a 3:4 aspect ratio. So you don't need to do the math to calculate the height. And then obviously every time you crop an image, or when you resize an image, you need to tell what you want to do. Like, do you want to crop it? Do you want to pad it? Do you want to stretch it? And when you crop it, where's the center of your crop? Is it in the center of the image? Is it left? Is it right? And yeah. So, and when you pad it, you want a background color, so you can pass that also. And at the end, we build this image, sorry, and we will just store it back to the bucket. And when I'm speaking of buckets, so we have 2 buckets and 1 CloudFront that we generate. So we will have a cache bucket. That's where we store our resized images. And what we've done here, we use it as a website. And with the website, we can actually add routing rules. And the routing rules are based on conditions. So here, automatically, if now my bucket returns a 4 or 3, so not found, that's the NS3 thing. It's if he cannot find the file, he actually returns a 4.3 and not a 4.4 because he cannot access to the bucket. But then we have a redirect rule, and we automatically transform the response from the S3 bucket, or from the S3 website bucket, to a 307, so a redirection, to a new URL that I built here from using the HTTP API that we define in this stack with the same URL suffix. And that's where actually we can easily do the redirection from a missing file in S3. The source bucket, that's just a simple private bucket in which we will store our raw images. We also have a CloudFront distribution that will use the cache bucket behind it. Again, nothing fancy here. We are just like forcing a little bit caching. So if no TTL is defined on the files, we store it for 1 year. But everything that's not 200, so the 400, 403, 404, we will store that for only 10 seconds. And everything that's 300 is not stored in a CDN anyway, so we don't have to define them here. And in a nutshell, that's it. So an API gateway, a Lambda function, 2 bucket, and a CDN, and a CloudFront distribution. So I think we can now have a look. So I already deployed that in advance, so we don't have to wait for it to deploy. Especially CloudFront is kind of slow to deploy. Okay, just opening my AWS console so we can have. Okay, as you see here, I have my two buckets, originals and cache, so they're all empty. So let's now add some images to those buckets. Just an S3 upload. Into that. So I have 2 images here that I'm going to upload. So I have 2 images, one called Switzerland Mountains that I put in a root folder called Landscapes. Let me put that a little bit bigger so less strain on your eyes. And another other one is a picture of the Eiffel Tower in Paris that I put into a root folder called City. If now we look at these images, the raw ones that I have here, so that's the view of Paris, and if I go to 100%, you see it's quite big. And then the same, obviously, with the Switzerland mountains. So again, if I go 100%, you see that's like way bigger than my screen. If we look at the 2 files, so this one is a 4,000 by 6,000 pixels in JPEG. And this one will be something similar, I guess. Yeah, 5,700 by 3,800. And now if back to our buckets, we now see in originals, now we have our 2 images, one in the city folder, which is our Paris Eiffel Tower. And in our landscapes, we have our Switzerland mountains. So how will that look now that we when we actually request the file. So let's just call it like from the browser here. So that's my CloudFront distribution that was created. Obviously, in real world, you want a domain on it. I have here my path to my raw image, landscape, Switzerland mountains, a version, and now the dimension. So I want this image to be 640 by 480, and I want to crop it. And I want WebP format. So let me disable cache, preserve log. Okay. So now let's make the request here and observe on the right the flow. I will go through it, no worries. And now, okay, we got an image, like if you remember the huge image that I showed you before. Now it's 640 by 480 image. And here, let me just filter on our image to not have. So we can see 307 redirect. Then we went to the API gateway here, return 301, or apparently 301, not a 302. And then we were giving back, and then back to the CloudFront. And now we have 200 OK coming back. The image is coming back, and we can see here it's a miss from CloudFront, so it wasn't served from the cache. If now I refresh the same URL here, let me clear the history here, and I refresh. Now you see directly one request only. We didn't go to API gateway. And I was expecting a hit from CloudFront here. Oh. Yeah, now. And now we have a hit from CloudFront. So now this second reload, I don't know why the first one didn't go as a hit. But now I have my image is served directly from the CDN near me, as you can notice here, the POP ID for CloudFront. So, okay, so far so fun. Now, let's say we have another client that needs something a little bit bigger. Now so here is the same, as you can see, the same URL, landscape Switzerland, width this time the width is 1 to 80 for and 480 height. And so now we are going again to the redirect flows. And now we have our image that is the same image, but on a different aspect ratio and wider, and we cropped it so that it fits the sizes we want. The other example with the Eiffel Tower is speaks a bit better on the cropping part. So here I took the Eiffel Tower image, and you see that our Eiffel Tower is cropped. But we need to have this aspect ratio of the image in our website. That's mandatory from marketing. They need that size. They cannot have vertical. But obviously, an image of the Eiffel Tower with the Eiffel Tower cropped, that's really not good. So let's a little bit change our URL here. Instead of putting just crop, we will put a crop with a gravity top. So it means that instead of centering our image, we will crop, but we will align to the top of the image. And now we can see the exact same source image. Instead of cropping this part here from the image, I just crop the top part, and now we have our Eiffel Tower totally in view in our picture. Another example. Now we would need a square image for 480 by 480, but we want to see the whole row image. So we will need to pad the sides. So here I'm padding with white. I can also pad to make it more visible. I pad with red, so that every time creates a new image. And now we have a nice square image, but with the full view of our raw image, and that's actually a good solution if you want to create your only square images, but you don't want to lose anything from the original images. And now remember the mountain we had at the beginning. That's gonna be my last example. So that's my 640 by 480 image. But now if you come with a device that has more pixels, you still want it's still 600 pixels width, but you need to double the pixels to go to a retina display. So you take the same URL here, but you just add the parameter DPR2 with the same width and height. And now you load that, you just get the image on the double size. So now if we go to our cache bucket to see what we generated here. So now we can see in our cache bucket, we still have the same root folders as the raw bucket. We still have the name of the image, but now it's not a file, it's a folder. If you go inside, we have our version, and now we start to have the path for all the sizes. So, and here we get our cache image. So this version here is 66K. If I go to the origin image that we had, was 5 megs. So we went from 5 megs to 66K. And if you start to serve a lot of images to customer, this kind of reduction like has a huge impact on internet speeds and on your bill. Okay, so we kind of saw it in action. So what did we build here? So we built something quite simple that at first view was looking very complex. And we built something that's cost effective. So we only have a new format that will need processing. So every time your browser requests the same format, nothing happens, just the CDN that serves the image. So, and now if you have more customers, I put client here, but it's more customers or more visitors coming that all have the same device, there is no additional processing. You just serve your image from the CDN. And in that case, if everyone has the same device, you only pay for storage and for CDN, for transfer cost. And there's no cost for idle. So if suddenly nobody comes to see your images anymore, you don't have to pay anything. It's a scalable solution because every new dimension, I put format with small dimension, every new dimension is only created once. If now you have a big news outlet that features your article and you have a huge increase in client requests, as long as your images are, the sizes needed are, the dimension needed are pre-generated, you will get only CloudFront and S3 interactions. And we all know that CloudFront and S3 can handle increasing requests. With S3, you have infinite storage, or actually you don't have to care about storage because a few folks at AWS will take care of that for you. And the solution can also handle any future DPR or screen sizes. So let's say that next year, everyone will have a 2K screen, but we can handle that. We don't have to pre-generate new images and redeploy the website. It will just generate them when needed. I tried to do some little cost example. So I took an example, images uploaded each month. Each month we had 1,000 new images at 4 gig an image. Each image will need 10 variation because roughly 10 different screen sizes in the world. And this 10 variation in total will take 3 gigabytes of space. To create a variation, let's say 1.5 seconds, we've seen before it's a bit faster than that. And each month we have 1 million of requests for images across all 10 variations. And roughly, let's say I went 600 KB each image on average. So that's 10,000 API requests, roughly a little bit more than 1 cent. We have 10,000 Lambda invocation, that's 0.2 cents. 10,000 Lambda execution, that's obviously the expensive part, 25 cents. We need to store those images. So again, 10 cents, 10 cents, yeah, and we come to a total of 44 cents. I, on purpose, didn't account for CDN costs here, because regardless of what backend you are using, be it a server, be it Kubernetes, be it API gateway, your CDN will always be there. And you will always have to serve those images to a CDN. But yeah, just to say, it's, I would say, pretty cheap to serve your images in that way. So, and is it perfect? Obviously not. Nothing is perfect. Yeah, you always have tradebacks. So we could improve that by reducing the first execution time by pre-generating the variation that we need. So you kind of know what are your biggest consumers. Probably perhaps a desktop, so it's a DPR1, and you know your image sizes, so you could pre-generate all the images, all the variation that you need every time that you send an image to your row bucket with an S3 Lambda trigger. You will just trigger the same function, it pre-generates the variation. We could also reduce cross-region latency by replicating buckets from one region to another and having the CDN fetch from the nearest bucket. Yeah, I won't go too much into CDN and S3 backends, but if you are in Australia and you want to see the demo I've made, obviously your image will be need to fetch from Germany, because I used all the buckets in Germany, and that adds latency. Automatic JPEG WebP, yeah, that's no more a thing. Like everyone is doing WebP nowadays. I think Firefox moved to WebP a while ago, and there was the last one not supporting it. One thing that the keen eyes would have noticed is if now I just change from 1 pixel my width of my image, it generates a new variation. And obviously that will add cost, generation, storage, and so on. So we could add a CloudFront function to normalize the URL and probably generate to the nearest 100, or just reorder the arguments so that if I put width first or height first, it's not a new image. And something I've never done, but I wanted to do and never went around it to do it, is extract the metadata on images when the raw image is loaded, like extract the EXIF information, run it to Amazon Recognition to get some tags on the image, store that nicely in a DynamoDB or an OpenSearch, and then do something with all that data. But yeah, on the client side, I think there's a lot of things happening. I call it the future. It's more like the present now. There are two people that are still not willing to play nice, and that's Firefox and Safari. And it's something called client hints. So on your server and on your client, you will need to allow client hints, and then tell what client hints you want to send. And this client hints is the browser telling the server what he can do. So what's the viewport width? What's the downlink speed? What's the DPR? What's the width of my screen? What's the width of the div I'm in? And with that, you can have only a single URL for your image. You don't have to do the SRC sets, and your client will be able to send that information to the server passes it and will return the right image size. That will reduce a little bit the heavy lifting on the client side that we have now. Yeah, and that's it. So I put Q&A. I don't know if people have questions. So now it
Yeah.
takes 1 hour. My God, I didn't I didn't prepare for that. I'm
So
happy.
we
Yeah.
have some questions. I think one question from Madhavan. Uh, if you can add it to the screen, Susit.
Yes, one second. I'm just trying to find that. Ah, okay. Yeah. So we have one question from Mahadevan, Daniel.
Oh, I didn't know that. CloudFront service is not available in the government cloud, the government account. That's a bummer because obviously, like serving on the web without a CDN, that's like, yeah, it's like no, it's like going outside without sunscreen. Yeah, and so for that is if CloudFront is not available, is there like another CDN like Akamai that you're allowed to use? And you could do the exactly same with any other CDN. So I use CloudFront here because it's an AWS product and it fits nicely in my YAML file, and I don't need to sign contracts to be allowed to use it. But any other CDN will work. The only goal here is that the backend, your S3 bucket, will need to return a redirect. Your API gateway will need to return a redirect. Now, the CDN that you use, Cloudflare, Akamai, or whatever, doesn't really matter.
Okay. So that's the answer for your question, Mahadevan. So if you don't have CloudFront, still you can use some other services. And yeah, uh, so I think that's it from the questions
Yeah.
side. We have only one question from the
Okay. So it means that my presentation
audience.
was super clear.
Yeah, yeah,
Or,
it
or,
was
or
really
too
nice.
complicated and nobody understood what I said.
No, no, no. It was really nice, and even for me, it was a new way to handle those images because I have seen in the past where front-end developer is struggling a lot to handle those screens, fitting those screens in different devices. So yeah, it was a nice, interesting way to handle images.
Yep.
Yeah, and for the story, I'm using that for my own. I'm hosting my own photo gallery, so I don't use Google Photos or Picasa or whatever. I created my own, and that's what I'm using. Actually, that's why I created it, was for my own use. And yeah, it's running since 6 or 7 years now, and I really don't maintain it. So it's just there and it runs, and it works nice on every device. So I'm not Brian from, was it Brian from design that was like totally freaking out? Yeah, I'm not like him. I'm more like the Bob from development. Yeah, I forgot the names I gave to my characters.
Okay. So yeah, you have any questions, Susit?
No, no, I'm good. Yeah, I mean, again, would like to thank Daniel for joining us early in the morning, sharing his knowledge about it. I'm pretty sure there's quite a lot of insights to pick up from your session. Daniel, thank you so much for joining us, and really looking forward to having you again in the near future.
Sure, no problem. Thanks for having me.
Thank you so much.
Yeah.
Thank you
Have
so
a
much.
nice
Thank you.
day. Have a nice week, a nice month.
Thank you so much. Bye
Thank you.
bye.
Bye.
Bye bye. Okay, so that's it from the today's presentation, and uh, from next month, I think probably we will come up with more speakers. From the last 2 months, I think we have only one speaker for each session, but yes, we will be working towards giving you guys more sessions in a single day. So yeah.
Yeah, and if any of you are interested in presenting, please do reach out to either Dharmendra or me, and we'll be more than happy to host you. Any use cases, any stories, anything cool, anything new, anything old that you migrated to serverless, we are here to host you, and we'd like to share. We'd like to give you the platform to share your story with the rest of the developer world. So, looking forward to hearing from all of you on if you're interested to present here. And thank you so much, and have a great weekend ahead. Bye bye.
Thank you so much. Bye bye.